scientific notation. So some decimal number times 10 raised to some power. You see it a lot in science classes, chemistry in particular, since we're dealing with things of very, very small radii like atoms, or a very large number of particles in, say, a mole of atoms. So, scientific notation, the first golden rule that you need to remember is that there can be only one whole number, one non-zero number in front of the decimal place. So let's start with small numbers, our smaller decimal places. Something like this number. So you know that this is the tenths place, 1 over 10. This is the hundredths place, 1 over 100, which is 10 to the negative second. You know this is the 1,000ths place, 1 over 1,000, 10 to the negative third, and so on and so forth. So to put this in scientific notation, we're going to bounce this decimal until there is, you guessed it, one non-zero number in front of the decimal. Here we go. So 5.6, that is the decimal of which I spoke, times 10, since all those zeros, as we said, tenths, hundredth, thousandth, all multiples of 10 with zeros. We bounced it 1, 2, 3, 4, 5, 6 places, and since these are all decimals, it is a negative exponent. One more example. Do an even smaller number there. Same deal. We are going to take that decimal and bounce it until one non-zero number is in front of that decimal. Onward we march. 7.02 times 10 to the negative, since this is a decimal, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th. 7.02 times 10 to the negative 10th. Sometimes, another way you'll see these written is instead of times 10 to the, you'll see a capital letter E. So we could also write this as 5.6 E negative 6. So this E takes the place of times 10 to the. Down here, same deal. This could be 7.02 E negative 10. Exact same numbers, just a different way of writing it. If we were to go the other way, if we were given an exponent and asked to put it into its regular form, we would start off with the decimal. I know this is a negative exponent, so I'm going to be going this direction. How many places? 5 places. 1, 2, 3, 4, 5. Fill in my empty bumps with zeros. And there it is. If we were to deal with larger numbers, so now we're going to be multiplying by tens, hundredths, thousandths, 10 to the second, 10 to the third, 10 to the fourth. Positive exponents this time. So something like this number, for example. We have no decimal to start with, so we pretend our decimal is here at the back, and we're going to bounce it until, guess what? One number is in front of that decimal. Here we go. So 2.3 times 10, positive exponent this time. 1, 2, 3, 4, 5, 6, 7 places that we moved that decimal. Again, I pretend my decimal is in the back, bounce it until there is but one number in the front, times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th place. There. If we were to go the other way, so 5.26 times 10 to the 4th, start off with 5.26. We're going to bounce that decimal this direction to get our larger number, and we're going to bounce it 4 places. 1, 2, 3, and 4. Fill those empty bumps with zeros. And there is our final answer. Remember again, we can replace this times 10 to the with an E, just to save some of that pencil lead there. It's also the button that you can use in your calculator. There is usually an E button, and it has to be the capital E. Don't mistake the lowercase e, but that's a completely different function. So I hope this clears up some of the misconceptions about scientific notation. If you have any further questions, make sure you email me so we can get that straightened away. Thanks.